Okay, hello, welcome to the next video, the final video of Unit 20.1. And today what we're going to be covering is we're going to be covering the reduction of carboxylic acids. This is the last video. So basically what we're going to do in this video is we're going to review a part of Chapter 10, and we're also going to introduce what the reduction of carboxylic acids are. So basically, hopefully what you remember. If not, well, you got to remember it from this video. Is that we can cause alcohols, primary, secondary, to oxidize to aldehydes, ketones, and carboxylic acids. So you would have done this in Unit 10, and hopefully you remember some of that. This is kind of a reaction series that alcohols can be oxidized in different ways. So hopefully what you remember is that we can oxidize a primary alcohol to a aldehyde. We can oxidize a primary alcohol to a carboxylic acid, or we can oxidize a secondary alcohol to a ketone. So there's the three different reactions that we can do. Is we can oxidize primary, or secondary to a ketone. And what you kind of need to remember, or what you definitely need to remember for this, is what oxidizing agents we use and when. So when we use these oxidizing agents. So basically what we're going to talk about first is we're going to talk about the two different oxidizing agents that you must know and the difference between them. So this hopefully is, like I said, hopefully this is a review. So we've got K2Cr2O7, one of the ones you need to memorize. The other one, KMnO4. So the names for these are potassium, potassium dichromate, and we've got potassium permanganate. And this one, potassium dichromate, is a soft oxidizing agent, and potassium permanganate is a hard oxidizing agent. And we're going to go over what that means in a second. So let me just erase this top part, and then we can continue on. So okay. So basically, the difference between a hard and a soft oxidizing agent. A hard oxidizing agent will react it immediately. Is gonna work right to the final product immediately. So if we take an alcohol and a primary alcohol, so I'll try to draw that with RCOH, and we mix in KMnO4, what you're going to get is you're going to get right to the carboxylic acid, RCOOH. So right to the carboxylic acid in one step. And there's not going to be any aldehyde intermediate or anything. We're just going to get the final product. Whereas a soft oxidizing agent, the difference is that we take RCOH, we're just dealing with primary alcohols now. You mix it with K2Cr2O7, and it's going to turn into an aldehyde, RCOH. And then if we keep heating it for a longer period of time, then finally we're going to end up at the final product of a carboxylic acid. So you can see that this reaction, right? This reaction jumps right to the final product. So we can't really control that. We can't really control the time that we're reacting it. We can't really control anything. Here we can control that. We can say, okay, we're gonna react. We're gonna take this alcohol and we're gonna put it in a reflux for 10 minutes, something like that. So this is the experimental part, is that if you reflux it for different amounts of time. So what a reflux is, let me just draw it quickly up here. We've got a heating pad. I'm going to draw like this. We've got a boiling flask. And above that, we've got a condenser with our water in and our water out. So what happens is that as this starts to boil, you want to leave it at its boiling point for a long period of time. As this boils, the vapors go up, condense, and drop back down into the solution. And then they boil again, they go up again, they condense, they drop back down. So you can keep it at its boiling point for a longer period of time without losing any of the solvents. That's what reflux is. So in this case, it's an experimental procedure. You reflux it for different amounts of time to get different proportions of product. If you reflux it for a very, very long time, you're going to make more carboxylic acids. If you reflux it for a short time, you're going to make different amounts of aldehydes, and it depends on what you want as your final product. Usually if you want the aldehyde, right, you need to find the best time to maximize your yield of aldehyde and minimize your yield of carboxylic acid, because this is just waste at that point unless you have another use for it. So that's what a soft oxidizing agent is. The reaction takes longer, needs more special reaction conditions, but we can reach this aldehyde intermediate instead of jumping right to the carboxylic acid up here. So okay, that's our soft oxidizing agent. So these are the two that you must know. Two that you must know, and their names and whether they're soft or hard oxidizing agents. So okay, let's talk quickly then about reducing agents. So I'm not going to really do any examples of that, just because I expect you to have done that in Unit 10. If you haven't, then you'll have to wait until I post some Unit 10 videos online. So the reduction of carboxylic acids, what we have is we either have a Q group, so a carboxylic acid, and we can reduce it directly to an alcohol, or we get the aldehyde. I believe we read it as CHO, so CHO group, and we could reduce that to an alcohol. So once I do a question, I'm going to do a question on this, and I'll show you how this matters, whether we can reduce aldehydes or reduce carboxylic. There also is a way to reduce carboxylic acids to aldehydes, but that's not part of the IB syllabus, so don't worry too much about that. But just know that there is a way. I'm not just skipping that. There absolutely is a way. It's just we don't need to know that way. And if you answer a question, doing something outside of the spec of the course, I'm not too sure you'll get the points for it. So let me give me a second. Okay, good. We're still recording. Sorry, I messed up recording in the last video, and I recorded this entire video, or actually I failed to record this entire video once. So basically what this means is that, this one, right, would be a harder reducing agent. So let's talk about what their formulas are and what their names are. So here we have sodium, aluminium hydride, and here we have sodium borohydride. And this one we can kind of consider it a softer oxidizing agent or reducing agent. So it does not reduce Cu, so it's not a strong enough reducing agent to reduce carboxylic acids. And this one is a hard one, so it reduces Cu to hydroxide. So we've got two different things right here, right? We've got another hard and soft. Down here we've got a soft and a hard oxidizing agent. So I'm going to do a question. I'll show you where this can come in handy. You know, the IB can ask you a question, something like OHCC. This is your starting product, and your ending product is, let's see. So we have our starting product and our ending product. So we say our starting product, organic chemistry is just the chemistry of functional groups. So we've got one here and one here, and we draw what they turned into. So this one turned into an alcohol, and this one turned into an alcohol. So we've reduced both of them. So if we've reduced both of them to an alcohol, it means we must have used a hard reducing agent. So in this case, you would have used sodium, aluminium hydride, and you'd have the answer right. You'd know what reagent you needed to use to reduce both of these. Or we can have a harder question. Let me just erase all this red. So I can't erase it all. I'm just going to erase as much as I possibly can. Okay. So now let's look at a little bit of a harder question. COH, and your final product is COOH. So you can see, right, from this you look at your functional groups and you say, okay, this one is maintained. So we didn't reduce the carboxylic acid, but we had an aldehyde and we've reduced it to an alcohol. So this is where knowing which one does which is very, very important. One reduces aldehydes, one reduces carboxylic acids. The carboxylic acid is maintained, so therefore we must have used sodium borohydride. We must have used a softer reducing agent. Okay, so I'm going to erase this really quickly, and I'm just going to, what's on the screen is what you need to have basically summarized in your notes and know how to answer questions based off of this. So go into your textbook, do the questions at the end of the chapter, because in chapter 20.2, this is the last video of 20.1, 20.2 is organic synthesis. So it's organic synthesis. So it's how to make a final product. The IB, what they're going to give you, they're going to say you start with this, you end with this, and you need to write out the 4 or 5 or 3 steps to get to that end product. If you don't know what reactants you have in your disposal, then you can't get your end product. You have no idea how to get your end product. So just make sure that you know these 4 and you know exactly what they do, because in my next video, we're really, 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 really going to need them. Okay, thank you for tuning in today. I'll see you in the next video.